For decades, it's been the stuff of science fiction, something you'd read about or something that would get stuck in canceled budgets. But after more than 60 years of waiting, NASA has just made an announcement, a truly historic one that is going to fundamentally change the future of human space exploration. Let's break it down. These are the words from NASA's chief, and they really do mark a pivotal moment. See, this isn't just another mission announcement. This is a declaration of renewed ambition. It's a promise to recapture the spirit that took us to the moon in the first place. And here it is, the bottom line straight up. By the end of 2028, a spacecraft powered by a fission reactor is going to leave Earth orbit and head for the red planet. This is not a concept, it's not a what if. This is the new official plan.
So what is the machine at the heart of this incredibly bold mission? Well, it's called Space Reactor 1 Freedom, and it represents a complete paradigm shift in how we travel through deep space. To really get it, let's look at the fundamental difference here. Think of our current chemical rockets as cosmic dragsters. They have immense raw power, perfect for that initial blast off Earth. Nuclear Electric Propulsion, or NEP, is more like a cosmic Prius. It's not about speed off the line. It's all about incredible efficiency and a continuous, gentle thrust that builds up to enormous speeds over time. This lets us move massive payloads across the solar system in a way we've never been able to before. So how does this actually work? Well, it's crucial to understand that the reactor itself isn't the engine. The nuclear reactor is really a power plant. It just sits there and generates a massive amount of electricity. That electricity is then channeled to these state-of-the-art ion thrusters, which use the power to push the spacecraft forward gently but relentlessly. Over time, that gentle push adds up to incredible velocity. And this number right here, 20 times, that represents a monumental leap in our capabilities. The reactor on SR-1 Freedom will generate 20 times more electrical power than the generators on the legendary Voyager probes. That kind of power makes really complex, energy-hungry missions to the outer planets not just possible, but actually practical. Let's get into the hardware. At its core, you've got the fission reactor. That, in turn, powers the xenon ion thrusters. But here's the really genius, pragmatic part. The main body of the spacecraft is something called the Power and Propulsion Element, or PPE. This is a multi-billion-dollar piece of hardware that was already almost finished for the now-paused Lunar Gateway program. So NASA is just cannibalizing it for this mission, which saves an absolutely immense amount of time and money. Now, let's talk strategy. Because, the technology is only half the story. The real breakthrough here is the strategic pivot inside NASA that's finally making a nuclear mission like this a reality. To really understand how big a deal this is, you have to look at the history. Over the last 60 years, NASA has spent more than $20 billion on different space nuclear programs, things like Prometheus and Draco, and every single one of them was eventually canceled. This long road of stalled progress is what makes this announcement so groundbreaking. And this quote from NASA's Steve Sanacor really nails it. He says the problem was never the technology, it was an execution problem. Past efforts, well, they just aimed too high, they had convoluted management structures, and they got bogged down in endless studies and bureaucratic delays. SR-1 is different. It's focused, it uses hardware that already exists, and it has a clear, non-negotiable deadline. This new way of thinking is part of a sweeping, agency-wide culture shift they're calling ignition. It's basically a top-down mandate to fix that very execution problem. It's about cutting through the red tape, to stop studying and start building, and to focus every single resource on achieving one major goal. It really is a return to that Apollo-era mindset. And this chart shows that pragmatism in action. The $4.5 billion Lunar Gateway program, it's on pause. Its most advanced piece, that power and propulsion element, is being pulled and repurposed to become the core of SR-1 Freedom. It is a decisive, almost ruthless move, but one that redirects a huge investment toward a more immediate, game-changing objective. Okay, but this mission isn't just about testing a new engine. Now we get to the really exciting part. Let's talk about what happens when SR-1 Freedom actually arrives at Mars. After a year-long journey across space, the spacecraft will deploy its secondary payload. And it's not a rover, it's a trio of advanced, autonomous helicopters called Skyfall. They're inspired by that wildly successful little Ingenuity drone, and their job is to scout the Martian surface from the air. And their arrival is pure drama. First, you've got the hypersonic plunge. the capsule slams into the Martian atmosphere at more than 5 times the speed of sound. A supersonic parachute deploys, violently slowing the craft down. The heat shield is jettisoned, and then comes the moment of truth. For the first time ever, a mid-air deployment. The 3 helicopters are just released, and they have to fly down and land themselves on the surface of Mars. Once they're safely on the ground, the Skyfall drones get to work. Their main job is to act as advanced scouts. They'll use ground-penetrating radar to hunt for the one resource that is absolutely essential for a human outpost: water, in the form of subsurface ice. Finding that is the key to unlocking a permanent human presence on Mars. So let's zoom out. Why does this one mission, this one piece of technology, matter so much? Because this is about igniting the entire future of human exploration. So what doors does this nuclear key truly unlock for us? It's not just about getting to Mars a little more efficiently. It's about fundamentally changing what is even possible for us in space. The really crucial point to remember is that SR-1 Freedom is a pathfinder. Its main goal isn't just dropping off some drones. It's to achieve what they call flight heritage. It's about proving, once and for all, that these nuclear systems can be built, launched, and operated safely and reliably in deep space. Its success sets the stage for everything that comes next. And that future is, well, it's breathtaking. Success here makes a permanent moon base, powered by reactors on the surface, a real possibility. It makes a faster, safer trip to Mars for astronauts possible. And it unlocks a whole new golden age of robotic exploration, making missions to the icy moons of Jupiter and the farthest reaches of our solar system not just dreams, but actual destinations. For 60 years, space nuclear power was a promise that was always deferred. But now, with a pragmatic plan, with repurposed hardware, and with a renewed, ferocious sense of urgency, that promise is finally being fulfilled. The next great leap for humanity has at long last been ignited.